Hello students, today in this video we'll see a problem from partial differential equation. Here I have taken the concept elimination of the arbitrary function. So here the problem is f of x plus y plus z comma x y z equal to 0. So we need to eliminate this function, and we need to obtain a partial differential equation. So that is our main objective now. Okay, so we'll start the solution. So we can say that the given problem is of the type phi of u comma v equal to 0. Here u equal to x plus y plus z and v equal to x, y, z. If you compare these two equations, you can say that the value of u is x plus y plus z and the value of v is x, y, z. So that's what I have taken. Okay, after writing u and v, you need to write dou u by dou x. So dou u by dou x is nothing but we need to differentiate these terms with respect to x. If you can see here, we have x. If we differentiate x, the value is 1 plus. If we differentiate y, the value is 0 because the differentiation is with respect to x. So if we differentiate y, its value is 0. Next term, if we differentiate z, the term will be dou z by dou x, because in z we have x and y. We have seen here z is nothing but a function of x and y. So we can differentiate z with respect to x as well as y. So if we differentiate z, the term is dou z by dou x. So this is equal to 1 plus dou z by dou x. Dou z by dou x is nothing but p. So dou u by dou x value is 1 plus p. Next, I'm going to find dou u by dou v. So dou u by dou v is nothing but dou u by dou y. I need to differentiate u with respect to y. So this is my u term, so I need to differentiate this. So if I differentiate x with respect to y, the value is 0. Then if I differentiate y with respect to y, the value is 1 plus if I differentiate z with respect to y, then the value will be dou z by dou y. Okay, so this is equal to 1 plus dou z by dou y. So dou z by dou y is nothing but q. So dou u by dou y value is 1 plus q. Okay, after finding this, we need to find, similarly, we have v equal to x, y, z, right? So we need to find dou v by dou x and then dou v by dou y. So we need to differentiate, right? So we'll differentiate now. So you can see here the x terms are in here. X will be here as well as in here, right? Because z contains the term x and y, right? So we have to differentiate with respect to with respect to x. So x term will be here. In both the terms we have x. So y is in multiplication, take y outside. So we just need to differentiate x, z, right? We will differentiate only the terms x and z. Okay, so we'll use the formula differentiation of uv. Differentiation of uv, we know that it is uv dash plus vu dash. So this is my differentiation of uv. So what is my differentiation of xz? So differentiation of xz will be u term is x, so x, v dash, v is z, so v dash will be dou z by dou x plus v. According to here, v is z into u dash, u is x, so u dash is 1. So this is xp plus z. So differentiation of xz is xp plus z. Okay, so I'll write here. So this is equal to y into differentiation of xz is, I find xp plus z. So if I multiply y inside, this is xyp plus yz. So this is my dou v by dou x value. Okay, and then next I'm going to find dou v by dou y. So I need to differentiate y terms, right? So y term here we have y term, and in here in z also we have y term. So in these two terms we have y terms, right? So we need to differentiate these two terms. So x is in multiplication, so I'll write it as it is. So I'll differentiate yz. Okay, so differentiation of yz. So differentiation of uv, we know that it is uv dash plus vu dash. This is the formula. So differentiation of yz will be, if you say if you see u is nothing but y, v is nothing but z. So if you apply in this formula, it is u in place of u we have y, so y v dash. So we need to differentiate this z. So if we differentiate this z, it is dou z by dou y plus v is z, u dash, differentiation of y is 1. So this is y cube plus z. Okay, so this is my differentiation of y z. So I'll substitute the value here. So x into differentiation of y z, it is y cube plus z. Okay. So this is my dou v by dou y value. Okay. And at last I have to substitute it in the formula to obtain the PDE. Okay. The solution of the given form is determinant of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So this is equal to 0. So this is the formula. This is the solution to obtain the PDE. Okay. So we'll substitute the values. Dou u by dou x, it is nothing but 1 plus p. Dou u by dou y is 1 plus q. So I'll write here 1 plus p, 1 plus q. Okay. And then I'll write the value of dou v by dou x, dou v by dou y. Dou v by dou x, it is xyp plus yz, and here dou v by dou x dou v by dou y is xyq plus xz. Okay, I'll write this value now. xyz plus xp, xyz plus one minute girls, I'll write it once again. So this is 1 plus p, 1 plus q, xyp plus yz, this is xyp plus xz, so this is equal to 0. Okay, this is xyq plus x. Okay, now I'll find the determinant of the terms. So to find the determinant of the terms, first I'll need to multiply these two terms. So this is 1 plus p into xyq plus xz, and then I have to put minus, and then I will multiply these both terms, that is 1 plus q into xyp plus yz. So the determinant is equal to 0. I'll put equal to 0. Now I need to multiply these terms. So first I am going to multiply these terms with 1. So 1 into xyq, it is xyq. Then 1 into xz is nothing but xz plus p into xyz is xypq, and then plus p into xz is xzp. Then minus sign is here, I'll write it as it is. Now I'm going to multiply these terms inside. So 1 into xyp is xyp, 1 into yz is yz, then q into xyz is xypq, then q into yz is yzq. So this is equal to 0. Next I'm going to take this minus inside. So I'll write xyq plus xz plus xypq plus xzp minus xyp minus yz minus xypq minus yzq. This is equal to 0. Now you can see xypq minus xypq, it will get cancelled and no other terms remains, right? So I'll write the remaining term. The remaining terms are xyq plus xz plus xzp minus xyp minus yz minus yzq equal to 0. Now I need to take the p terms. You can see here the p terms are here and here, right? P here it is and here it is, we have p term. So if you take the common terms outside, if the common term is xp is the common term in both here. So if we take xp commonly outside, we'll get z minus x. So here we have z minus, and here we have y, so z minus y. Okay, so p terms I have taken. Now I will take the q terms. If I see the q terms are here and here. Okay, so in these q term I can see that yq is on both the terms here and here. Yq is the common term, so I'll put yq. I'll take yq commonly outside. If I take yq commonly outside, here the term remains x. Minus sign is here, minus. And here the remaining balance term is z. So into z. Okay. And then the last remaining terms are xz and yz. So xz and yz, if you see here the common term is z. So if I take z commonly outside, it is x, here it is x, here it is minus y. So minus y, this is equal to 0. So I am rewriting this term. So x into z minus y into p plus y into x minus z into q plus z into x minus y equal to 0. So this is my partial differential equation. This is a PDE. How I am saying that this is a PDE? Because we have the partial derivatives p and q here. So p and q are the partial derivatives. So in an equation which contains the partial derivative is said to be partial differential equation. So this is my partial differential equation. Hope you understand. Thank you so much.